The first lecture, I will discuss about definition of solution, types of solution, solubility, concentration, vapor pressure of liquid solution, ideal and non-ideality of the solution. Then in this second lecture, this is the second lecture of solution. In this second lecture, I will discuss colligative properties, abnormal colligative properties and Van der factor. In our 12th syllabus, that is NC NRT base, okay, the definition of colligative properties, that means colligative properties and determination of molecular mass. What is this? Colligative properties and determination of molecular mass. Mass of solute or maybe solvent, no problem. Okay. Now what is the colligative property? Colligative property, the property of a homogeneous mixture or a solution, the properties of solution which only depends on solute particle present in the solution. So the properties of solution which only depends on the solute particle present in the solution is known as colligative property. Okay, এই colligative property আমরা কতগুলো colligative property আছে solution? The number of colligative properties in solution is 4. Colligative properties one is relative lowering of vapor pressure. Relative lowering of vapor pressure. Number 2, elevation of boiling point. Number 3, depression of freezing point. Freezing point. And 4, osmotic pressure. These 4 colligative property I will cover in this lecture. Okay. Now, relative lowering of vapor pressure. What is this? Relative lowering of vapor pressure. Relative lowering of vapor pressure. What is the relative lowering of vapor pressure? And what is actually vapor pressure? The vapor pressure is the force exerted by the vapor on per unit area of the solution or solvent. Okay. So vapor pressure is the pressure exerted by the vapor on unit surface area of liquid is known as vapor pressure. Let us consider a container and there is another similar container. It contains solvent, it contains solution. এই কন্টেনারের মধ্যে সলভেন্ট আছে, পিওর সলভেন্ট, দ্রাবক, দ্রবণ, দ্যাটস মিন এইখানে যদি কন্টেনারটা ক্লোজ থাকে তাহলে এখানে নাম্বার অফ ভেপার পার্টিকেল, এখানে হিট করলে নাম্বার অফ ভেপার পার্টিকেল যা হবে এখানে নাম্বার অফ ভেপার পার্টিকেল কমে যাবে। Why it is decrease? Here is higher because this contains solute particle, okay, in the surface. সব জায়গায় আছে solute particle, কিন্তু এই সারফেসে solute particle আছে। There are so many solute particles. These solute particles resist to move the solvent particle to our upper side, okay? অর্থাৎ এখান থেকে the solute particle always resist to move the solvent particle which is escaped from the solvent or solution. এখানে সেই solvent particle গুলো নেই, এই solute particle গুলো নেই, there is no solute particle, so there is no resistance, only solvent will vaporize, okay? So number of vapor particle in pure solvent is high, hence the vapor pressure of the pure solvent is higher than the vapor pressure of the solution. Now what happened? You can say the vapor pressure of pure solvent is P0 and vapor pressure of solute is PS. Since the number of vapor particle in pure solvent is higher, then P0 always greater than PS. So this will be positive since P0 is higher than PS. PS is the vapor pressure of the pure solvent in solution. That's mean vapor pressure of the solution divided by P0. What is this? Or according to Raoult's law, PS proportional to X2. What is this? Or we can say the PS or PS, that's means solute, PS solution is equal to P of solvent into X of solvent. What is this? The pressure is proportional to mole fraction. Since there is no vapor pressure of the solute particle, because solute is non-volatile, if solute is non-volatile, then what happen? PS equal to P0 into X1, then PS by P0 equal to, because vaporized particle always from the solvent, not solute, because solute is not the volatile, okay? Then equal to X1, then 1 minus PS by P0 equal to 1 minus X1. X1 is the mole fraction of the solvent. Then what happened? P0 from here, or from here we can write 1 minus PS, that is P0, LCM is P0, the P0 minus PS equal to 1 minus X1. This is actually 1 minus X1 equal to X2. We already discussed in lecture 1. Okay? So what happened? This is the delta P. What is this? Delta P divided by P0. What is the P0? P0 is the vapor pressure of the pure solvent equal to X2, or This is the lowering of vapor pressure. P delta P is the lowering of vapor pressure divided by P0. Then this is a ratio, that is relative lowering compared to P0. Since it is delta P, then compared to P0, this is the lowering of the vapor pressure. Hence it is known as relative lowering of vapor pressure. What is this? Actually, relative lowering of vapor pressure. Relative lowering of the vapor pressure. The relative lowering of vapor pressure depends on the mole fraction of the solute. So, what is this? Mole fraction of the solute. So, relative lowering of vapor pressure depends on the solute particle. Okay? Hence, it is a colligative property. So, relative lowering of vapor pressure is a colligative property. And now, delta P by P0 equal to x2, and now x2 can be converted in this way. x2 equal to n2 by n1 plus n2. What is this? n2 is the number of moles of solute divided by number of moles of solvent plus number of moles of solute. So x2, we can write x2 in this way, that is n2 by n1 plus n2. Now, if it is a very dilute solution and Raoults consider that it is ideal solution means it is very dilute solution. For dilute solution, the number of solvent particle is far greater than number of solute particle. Okay? In large amount of solvent, small amount of solute will dissolve. অর্থাৎ অনেক পরিমাণ সলভেন্টের মধ্যে অল্প পরিমাণ সলিউট ডিজলভ হলে সলিউটের অর্থাৎ দ্রাবের মোল সংখ্যা অনেক কম দ্রাবকের থেকে। তাই আমরা এটাকে নেগলেক্ট করতে পারি কম্পেয়ার টু n1. সো ইকুয়াল টু n2 divided by n1. Since n1 is far greater than n2, then we can neglect n2 compared to n1. এটাকে নেগলেক্ট করব না, এইটার সঙ্গে আমরা অ্যাড করলেই কি না করলেই কি। ওকে, then what happened for dilute solution? So it is very dilute solution, we already consider it. Now what is this? If W 2 gram solute dissolve in W 1 gram solute dissolve in W 1 gram solvent, and molecular mass of, and if molecular mass of solute is M2 and molecular mass of solvent is M1, then what happens? Number of gram divided by molecular weight, it is known as number of moles. Weight divided by molecular weight, it is known as weight divided by molecular weight, is known as number of moles. So N2 by N1 equal to, what is N2? N2 W by M2, W2 by M2. So this is the number of moles of solute, that is N2, and divided by N1 means W1 by M1. Okay, so we can write W2 by M2 into M1 by W1, where W1 is the weight of solvent, W2 is the weight of solute, and M2 is the molecular weight of solute, M1 is the molecular weight of solvent. Okay, so there is a relation. Relative lowering of vapor pressure, delta P by P0 equal to this. Then we can rearrange this equation. আমরা এটাকে rearrange করলে কি পাই? Can rearrange M2 equal to W2 into M1 by W1 into delta P and P0. So we can calculate molecular weight. We can calculate molecular weight from this expression. Okay. Now from the insanity problem, if we take that a mathematical problem, let us consider for a benzene, its vapor pressure, let us consider for a benzene, the vapor pressure of benzene from insanity problem, vapor pressure of benzene P0 equal to 0.85 bar, 0.85 bar. Okay, and pressure of the solution, that's mean PS, pressure of the solution is equal to 0.84 bar, 0.84 bar. Okay, if the molecular weight of the benzene, if molecular weight of benzene equal to 78 gram per mole, okay, then weight of the solute, let us consider if weight of the solute is W2 equal to 0.5 gram, 0.5 gram, okay, and weight of the solvent 39 gram, W1 equal to 39 gram, okay, then what will be the molecular mass of the solute? So for pure benzene the pressure is P0 is this, and for solution the pressure is this, molecular weight of the benzene is this, benzene is a solvent, and weight of the solute, that's mean 0.5 gram solute dissolved in 39 gram solvent, then what will be the molecular weight? Then molecular weight equal to, here W2 equal to 0.5 gram and M1, that is benzene 78 gram. P0, what is the P0? P0 is 0.85 bar and W1 is 39 gram, and here P0 minus PS, that is actually P0 0.85 minus 0.85 0.84 bar. Okay, bar cancel out, gram cancel out, it remains only gram. We can calculate it and we will get 170 gram per mole. Okay, the gram per mole, this is gram per mole. Okay, so this is the insanity problem. How we can calculate the molecular weight if W 2 gram solute is dissolved in W 1 gram solvent, if the vapor pressure of the pure solvent is this and solution is this. Okay, so in this way we can calculate molecular mass of any solute in solution. Then the point 2, the second colligative property, elevation of boiling point. What is this? Elevation of boiling point. At first we will learn about graph. Here it is vapor pressure. And this is a temperature. Okay, temperature in Kelvin. Now, and if it is 1 atm, it is 1 atm pressure. Then let us consider at 1 atm pressure, at T1 Kelvin temperature, this is T1, solvent will vaporize. Okay, solvent will vaporize. Now if we add some solute, then what happens? We already know the vapor pressure drop out or decrease. solute যখনই সলভেন্টের মধ্যে মেশাবো কি হবে, vapor pressure decrease করবে. The vapor pressure will decrease if we add some solute in solvent, then the pressure will decrease. If we add solute in solvent, then vapor pressure decrease. Then what happen? So automatically if vapor pressure drop, then it will not vaporize, because it will vaporize at 1 atm pressure, normal pressure. Then how we can increase the number of vapor particle? If we increase the temperature, then the number of vapor particle increase, that's mean pressure increase. Pressure from here, it will increase here, since temperature is shifted in the right hand side, then pressure is 1 atm, then in this way we will get the vapor pressure increase from temperature T1 to T2. The temperature from T1 to T2 shifted or temperature is increased, then number of vapor increase, that's mean vapor pressure increase. Then from the drop vapor pressure, it will again increase up to 1 atm pressure, then again it is vaporizes. Okay, মধ্য কথা বোঝা গেছে? অর্থাৎ ভেপার প্রেশার ড্রপ করে গেছিল, আমরা টেম্পারেচার দিলাম, অনেক ভেপার তৈরি হলো, তাহলে আবার সেই ভেপার প্রেশারটা ইনক্রিজ করলো, সেই সঙ্গে যেহেতু এটা শিফট করে গেছে তাহলে এটা আমি সোজাসুজি শিফট করে নিলাম। সো দিস ইজ দ্য গ্রাফ, অ্যান্ড এই গ্রাফটা কার জন্য? দিস গ্রাফ, ওকে, দিস গ্রাফ or this point only for solvent, okay, and this is for solution. This curve for solution, this curve for solvent. So there is a difference between to temperature. This is actually delta T B, since the difference of this temperature is actually boiling point difference. This is a boiling point, this is also a boiling point. So T2 minus T1 is the difference of boiling point from solution to pure solvent. This is for pure solvent, this is sheer solution. Okay. Hence, this delta TB actually increase. So this is the elevation of boiling point, and according to Raoult's law, this delta TB, the elevation of boiling point is directly proportional to the molality of the solution. What is this? According to Raoult's law, it states that the elevation of boiling point or difference of the boiling point from solution to solvent is directly proportional to the molality of the solution. So molality of the solution, then delta TB equal to, there will be a constant which is known as Kb into small m. Small m is the molality and Kb is the molal elevation constant. Kb molal elevation constant. Okay, molal elevation constant. Now, what is molality? You already know the molality. Molality is the number of moles present in 1000 gram solvent. Okay. Now let us consider W2 gram solvent, solute present in W1 gram solvent. Okay, and molecular mass of the solvent is M2. Now we can do in this way: W1 gram solvent when contains W2 gram or W2 by M2 moles of solute. Is it? Number of gram divided by molecular weight, it is the number of moles. M2 is the molecular weight of the solute. So W1 gram solvent contains M2 gram or W2 by M2 moles of solute. Then 1000 gram solvent contains W2 by M2 into 1000 divided by W1 moles. So this is actually 1000 gram contains this mole solute. So m equal to small m equal to W2 into 1000 divided by M2 into W1. Okay. So we can write delta TB equal to Kb into W2 into 1000 divided by M2 into W1. Clear? Now from this equation we can rearrange and we can get W2 or M2, that is M2 equal to Kb into W2 into 1000 divided by W1 into delta TB. Now if we can get the elevation constant, elevation of boiling point constant, weight of the solute in W1 gram solvent, and if we know the difference of boiling point, that's mean elevation of boiling point, then we can readily calculate M2. Clear? Now, from the NCERT, if we take one example, that the vapor pressure of benzene, let vapor pressure of benzene, if vapor pressure of benzene equal to vapor pressure of benzene equal to or we can take vapor pressure, এখানে আমরা প্রেসারটাকে না নিয়ে আমরা বয়লিং পয়েন্টটাকে নিই, it will be easy. If boiling point of benzene equal to 353.23 Kelvin, okay, clear. And W2, that's mean actually weight of solvent, boiling point of benzene is this, weight of solute equal to 1.80 gram, and weight of solvent equal to 90 gram, that's mean benzene is 90 gram, and another solute is taken 1.8 gram, okay. And rising of boiling point, boiling point raised to 354.11 Kelvin, then what will be the molecular mass or M2 if or given delta or Kb, that's mean elevation constant equal to 2.53, when Kb equal to 2.53 Kelvin kg per mole, এটা আমাদের ইউনিট হয়, ওকে। এই যদি দেওয়া থাকে তাহলে আমরা কি করব, জাস্ট এখানে বসাবো Kb, this one, W2, that's mean the weight of the solute, so Kb equal to 2.53, then W2, what is the W2? Solute, weight of the solute, that's mean 1.8, and this is 1000. W1 is just 90 gram weight of solvent, and delta Tb, what is the delta Tb? The final temperature was this and initial temperature was that is delta Tb equal to 354.11 minus 353.23, okay, and the value will be just 58. What will be the value of the molecular mass? I already calculated 58.0 gram per mole, okay, gram per mole, clear. So in this way we will calculate the molecular mass, no problem. Now the third point of the colligative property, what was the third point? depression of freezing point. Of freezing point. Depression of freezing point. Okay. So what is the depression of freezing point? And similar graph, vapor pressure in this axis, temperature in Kelvin, and what happen here? For liquid solvent, if it is liquid solvent, the curve is liquid solvent, temperature increase, it will be vaporized more, high. Okay. Then if for decreasing, okay, for solution, readily vapor pressure decreases, solvent vapor pressure high, and for solution vapor pressure low. Then if the vapor pressure of pure solvent is higher, then for solution is higher. And again at temperature from TF1, if it is TF2, okay, if it is TF1 and this is TF2, then what happened? This is decrease. Okay, this is again decrease. So since vapor pressure is decreases, then we need to decrease the temperature to get equilibrium or equilibrium vapor pressure of solid and liquid. Yes, solid and liquid. Then we need to decrease the temperature, and this is the difference. That's mean TF2 minus TF1, it will be negative. Okay, this must be a negative value. Clear? So depression of freezing point is also a colligative property, and this is equal to delta TF, and according to Raoult's law, this also the depression of freezing point is directly proportional to the molality of the solution. And from this equation we can again conclude that small m, what was the small m? Small m equal to 1000 W2 divided by M2 W1. Okay. Similarly, from elevation of boiling point, we already calculate m's, what is small m, molality is equal to 1000 into W2. W2 was the weight of solute, M2 is the molecular weight of solute, M1 is the weight of solvent. Then what happened? Delta T F equal to, there will be a constant, it is known as ebullioscopic constant or freezing point constant. Okay, depression of freezing point constant Kf into 1000 into W2 divided by M2 into W1. Then we can rewrite from here M2 equal to Kf into 1000 into W2 divided by W1 into delta T F. So again, in similar way, we can calculate M2, no problem. So we can calculate a different mathematical problem. If we not go to calculate M2 অর্থাৎ molecular weight যদি আমরা মাসটাকে আমরা যদি ক্যালকুলেট করতে না যাই, আমরা যদি ডেল্টা টিএফটাকে একদম ক্যালকুলেট করতে যাই, এরকম একটা ম্যাথমেটিক্যাল প্রবলেম যদি আমরা এখান থেকে নেই from NCERT. Let 45 gram of ethylene glycol, 45 gram of ethylene glycol, you may write down 45 gram ethylene glycol, that's means C2H6O2, C2H6O2 এটাকে নেওয়া হলো is mixed with 600 gram of water. Okay, calculate freezing point depression, calculate delta TF, freezing point depression and freezing point of the solution, and freezing point of the solution. Okay, what happened here? Just we know 45 gram of ethylene glycol is mixed with a gram of water. Then what happened here? The mass of water in kg, we can take in kg, no problem, or we can convert everything because there is a Kf. Yes, what is the value of Kf? We need Kf, clear, or we need actually M, delta Tf. If we need delta Tf equal to small m into Kf, small m into Kf. Okay, now what happened? Delta Tf we can calculate delta Tf, and what is the molality of the solution? What is the molality of the solution? Now 600 gram, that's mean 600 divided by 1000, it is equal to 0.6 kg. Okay, 0.6 kg of the solvent. Now 0.6 kg contains 45 gram, that's mean actually 0.73 হবে এটা। এই molecular weight দিয়ে ডিভাইড করলে এটার molecular weight কত হবে? এর molecular weight কত? We can calculate C6 2 into 12 plus 6 plus 2 into 16, that's mean 24 plus 32 plus 6, 2 plus 2 5 6 62, that's mean 45 divided by 62. Okay, what is this? This is the number of moles. So this number of moles present in 0.6 kg, then per kg means that is equal to 0.73. So 0.73 divided by 0.6 kg, this is equal to number of mole per kg that's mean molality, small m. Okay, this is the small m. Now what happened? If ato kf into small m, we know it. So small m is this. This is the small m. Then what happened here? Kf, this is for given actually 1.8 Kelvin kg per mole, Kelvin kg per mole, eta dewa thake. This is constant value. Okay. Then for delta T F equal to 1.8 into what was that? 1.2. 1.2. This is actually 1.2 mole. Okay. So this is the molality. Then equal to 2.2. 2.2. So delta Tf, since it is negative, then actually freezing point Tf equal to what was the actual freezing point? 273.15 minus 2.2, that was the actual, and this was the diffraction. Then now what will be the freezing point of the solution is this equal to 270.5, 270 point, that is 95. Okay, 270.95 Kelvin, 270.95 Kelvin, it will be the new diffraction of freezing point of the solution. Clear? Now there is another point of colligative property, that is actually osmotic pressure. What is the osmotic pressure? Osmosis or osmotic pressure. If there is a semi-permeable membrane, if it is solution and it is solvent, what is the osmosis? Osmosis is the process to penetrate the solvent molecule to the solution site through a semi-permeable membrane. Then there is a pressure difference. তাহলে এই সলিউশনটা আর সলভেন্ট আছে, তাহলে এখানকার মলিকুলগুলো এই সেমিপারমেবল মেমব্রেন দিয়ে এদিকে ঢুকছে। তাহলে যদি আমাদের এইটাকে বন্ধ করতে চাই, অর্থাৎ টু স্টপ দ্য পেনিট্রেশন অফ দ্য সলভেন্ট মলিকুল টুয়ার্ডস দ্য সলিউশন, দ্য ফোর্স এক্সাক্ট অন দ্য সলিউশন সাইড ইজ নোন অ্যাজ অসমোটিক প্রেশার। হোয়াট ইজ দ্য অসমোটিক প্রেশার? দ্য প্রেশার এক্সাক্ট, অর্থাৎ যে প্রেশারটা সলিউশন সাইডে দেওয়া হবে যাতে সলভেন্ট মলিকুলগুলো ঢোকা বন্ধ হয়ে যায়, অর্থাৎ দ্য প্রেশার এক্সাক্ট অন দ্য সলিউশন সাইড জাস্ট টু স্টপ দ্য অসমোসিস is known as osmotic pressure. Okay. Now, according to Van 't Hoff, osmotic pressure is denoted by pi. We know about PV equal to nRT for ideal solution or ideal gas. Then if P is just pi, then what happen? Pi into V equal to nRT. Similarly, Van 't Hoff says that the pi is the osmotic pressure is equal to nRT by V. The combined, there is 3 law like the ideal gas law. It is directly, we can write pi is the osmotic pressure is equal to n by V RT. So n by V RT. What is n? What is n? The pi equal to n by V means concentration, mole per liter. it is concentration. So C into RT, so pi equal to CRT. This is the equation for osmotic pressure. And what is C? C is the mole per liter. That's mean number of moles of solute per liter solution. Okay. আর একটা কথা, in colligative property, the relative lowering of vapor pressure, we use mole fraction of the solute. In depression of freezing point and elevation of boiling point, we use molality, because molality does not change with temperature. For this reason, in temperature related problem, we use molality. Depression of freezing point or elevation of boiling point, we use the temperature. Since the molality does not change with temperature, hence we can use the molality as appropriate way in the formula of the elevation of boiling point or depression of freezing point. So there is a point, okay, and here we can use normal concentration mole per liter, no problem, because there is a variable parameter, temperature is also can change, then concentration may change, no problem. Then this is mole per liter. Yes, this mole N equal to molecular weight divided by weight divided by molecular weight of the solute is equal to N. So this is V and RT. So what happened here? This is the N and this is V. So pi equal to W2 by M2 into V RT. So there is another formula. From here we can calculate M2 if we know the osmotic pressure of the solution and weight of the solute in V liter solution at a particular temperature, and R is universal gas constant. Its value is 8.314 joule per Kelvin per mole. Okay. Now in this way we can calculate the osmotic pressure also, and there is so many problems. In osmotic pressure we can draw a 3 diagram. If we take red blood cell, this is normal red blood cell. এই ব্লাড সেলটা নিয়েছি, why I am taking this type of blood cell here? There is a solution. If it is normal solution, that's mean water, okay, normal water, okay, it is normal water, then the density of the blood cell is higher than normal water, then it will swell or it will hemolysis. That's mean এটা ফেটে যাবে, ওকে, কারণ এইটার প্রেশারটা যদি বেশি হয়, অর্থাৎ in red blood cell the concentration of the red blood cell inside is higher than the normal water, then it will swell or it will hemolysis or এটা ফেটে যাবে. This type of solution is known as hypotonic solution. What is this? What is the hypotonic solution? When the concentration of a solution is very low or than the concentration of the solution of the red blood cell. Okay, and what happen here? If it is 0.84% sodium chloride, which is known as saline water, this is normal red blood cell, this is normal. এটা or hemolysis. Okay, and since the saline water and the concentration of the saline water and blood pressure is similar, hence there is no change of the red blood cell. But when, so it is known as isotonic solution. Isotonic solution means when the pressure of the solution or solvent or solution of the outside and inside is same, the pressure of the outside and inside of the cell is same, then it is known as isotonic solution. This solution is known as isotonic. If the pressure of the solution and pressure of the blood is not same, but the pressure of the solution side is higher than the blood cell, this is known as hypertonic solution. This solution is hypertonic solution. Okay, so this is the hypertonic solution, and for this reason, since the outside pressure of the blood cell is high, then it will be shrink or সংকুচিত হয়ে যাবে. Okay, shrink or কি বললাম, সংকুচিত হয়ে যাবে. Clear? Now there is another point. What was that? Abnormal colligative property. Abnormal colligative property. What is the abnormal colligative property? Do you know about the abnormal colligative property? When the solute molecule may dissociate or associate in a solution, কি হবে, যখন কোনো সলিউট পার্টিকেল সলিউশনের মধ্যে ডিসোসিয়েট হবে বা অ্যাসোসিয়েট হবে, তাহলে নর্মাল মলিকুলার ওয়েটটা সেম থাকবে না. লেট আস কনসিডার benzoic acid. Okay, what is this? Benzoic acid. This O is, there is a benzene, sorry, there is a benzene. There is another benzene. If we can write in this way, it will be better. It will be better. Sorry, এইখানে আমরা ডাবল বন্ডটাকে এখানে রেখে দিই, এইখানে ও এইচটাকে রেখে দিই, আর এই ওইচটাকে এইদিকে রেখে দিই. ক্লিয়ার? ওকে, দেন দেয়ার ইজ এ বেঞ্জিন রিং. অ্যান্ড এই গ্রুপটাকে যদি এইদিকে রাখি, তাহলে এটার মধ্যে একটা হাইড্রোজেন বন্ড, তাহলে কি হচ্ছে, In a solution, if two benzene dimerizes, এটা ডাইমার ফর্ম করলো, দুটো বেঞ্জিন মিলে একটা বেঞ্জিন হয়ে গেল, তাহলে মলিকুলার ওয়েট অ্যাকচুয়ালি ডাবল হয়ে গেল। তাহলে আমরা কি আর অ্যাকচুয়াল মলিকুলার ওয়েটটা পাবো? নাম্বার অফ মোলস হাফ হয়ে গেল। আমি 100খানা মলিকুল, ইফ উই টেক 100 molecules in solution, then we will get 50 molecules, this type of molecules, because 2 molecule dimerizes to form just like a molecule, like a one molecule, okay, অর্থাৎ দুটো মলিকুল একসঙ্গে একটা মলিকুল ফর্ম করলো, তাহলে 100 মলিকুলের জায়গায় আমি 50 মলিকুল পাবো, অর্থাৎ নাম্বার অফ মোলস ডিক্রিজ করে গেল। নাম্বার অফ মোলস পার লিটার আর নাম্বার অফ মোলস পার 1000 গ্রাম ডিক্রিজ করে গেল। তাহলে আমি কিন্তু নর্মাল কোলিগেটিভ প্রপার্টিটা পাবো না, অর্থাৎ ডেল্টা টিবি ইকুয়াল টু কেবি ইন্টু এম, তাহলে এম যদি হাফ হয়ে যায়, এম ইজ হাফ জাস্ট, then we will not get the normal colligative property, hence we will get the abnormal colligative property, or molecular weight will be double, okay, if it is dimerized. Again, if the molecule dissociate completely one or two or more ions, then it will occur again, because degree of dissociation or percent dissociation arise and the normal colligative property will be changed. Because if we see one, that's light sodium chloride, then this is one molecule, though it is not molecule, it is just formula, but in solution we will get Na plus 1 and Cl minus 1, so number of particle will be increased. Since the colligative property depends on the number of solute particle, hence number of particle increases, then colligative property also changes. For this reason, Van 't Hoff introduced a factor, since let us consider osmotic pressure equal to CRT, but since the concentration or number of moles per liter will be changed, then C will be changed, then it will be pi 1 or pi dash equal to C1 or T. Then how we can relate this? How we can relate? Then Van 't Hoff introduced that pi equal to I into CRT. Okay, there is a factor. It may be 1, 2 or less than 1, no problem. Okay, so this is the normal, this is the abnormal. Then how we can get normal to abnormal? That's mean if pi equal to CRT, or we can write here I CRT, okay, then what happen? Then it will be equal, this one and this one is equal, then what happen? What is I equal to pi dash by pi, okay, pi dash by pi. This is the abnormal colligative property, this is the normal colligative property, okay. That's mean this is experimental fact, okay, this is the experimental colligative property. Divided by theoretical colligative property. Okay, in this way we can write in this way delta T B dash by delta T B also. We can also write this is delta TF dash by delta TF, okay, or delta P dash by delta P, relative lowering of vapor pressure, okay. So normal colligative property, this is the normal colligative property, this is the abnormal colligative property, and it will be that the normal molecular mass divided by abnormal molecular mass, because colligative property is inversely proportional to the molecular mass or M2, okay, we already see that. Then it is normal molecular mass divided by abnormal colligative mass molecular mass. Okay, so in this way we can calculate Van der factor, and there are so many things in this chapter, okay, and about the NCERT, the theoretical or complete knowledge in this video is there, but if you get more information or more for joint entrance and NEET preparation, you must follow our channel, okay, and subscribe this channel to get NCERT based MCQ or NEET or for joint entrance and JEE Mains and advanced preparation, okay. You will get so many knowledge and its application, okay. Thank you.